Hey everybody, this is Larry. This is me trying to do an extra bonus premium prom. Oh yeah, I hit 1900, so maybe that's to celebrate. Let's do it. Let's do one that I haven't done before, hopefully. How do I do this? Yeah, medium, let's just say. And maybe we get an SQL question, because I feel like that happens a lot. Okay, not this time though. Oh, sorry friends. My watch is telling me that I should sleep soon. Well, let's finish this one quickly then, shall we? Hit the like button, hit the subscribe button, join me on Discord. Hope y'all are just having a great beginning of the weekend and all this good stuff. And April Fools and all this stuff. Don't get fooled by things on the internet, hopefully. I mean, but do have fun, I guess. Sorry, I'm going to drink a little bit sip of water. Today's problem is 426. Convert binary search tree into sorted doubly linked list. That sounds like a mess, actually. Circular doubly linked list, not just. Why is there a head? Oh, is that the head just to like say what? Well, okay, so the tricky part is that we have to do it in place, but oh, that's well, I didn't read even the second line, but I just read the title. Okay, so basically you want to use let's left is you go to previous and right is you go to next. Okay, and then let me think about this. That's actually maybe an interesting problem. I mean, it definitely is a problem that you don't really see in competitive programming. So I'm not gonna lie, sometimes I struggle on those just because it's almost like a different set of tools, I mean, it may not be hard, but it is new and different to me because in competitive, way rarely you're gonna see problems like this just because how are they gonna check it, right? And of course, even here, they can't really check it per se. What they I mean, but at the end of the day, you're only cheating yourself, right? So that's, you're supposed to do the enforcement yourself. Okay, so there are only 2,000 nodes. I thought maybe there's a linear thing, but now I'm thinking maybe there's a quadratic type thing, and whether that that would be interesting. The in-place part is a little bit scary because it means that, it's a little bit tricky, right? And there are a couple of constraints that I want to enforce a little bit on myself, at least initially. If I can't get it, then I'm, maybe be a little bit looser on the constraints. Is that because we want to do a transformation in place, I'm going to try, at least initially, like I said, to use only O of I want to say O of one extra space other than maybe stack. But we'll see how that goes. Because, like the core stack, maybe that's going to be linear anyway, so maybe that's an awkward thing to say. But then the other thing is that given that n is equal to 2,000, meaning that if you can do quadratic, then do you still need the extra space, right? Like sometimes the trade-off is going to be linear time, linear space, or n squared time O of one space, right? And then it's like, well, which one do I really want? Or n log, I don't know, something like this, right? So we'll play around with a couple of those ideas and then really think about it. I think these problems, to me, I don't always do them in the sense, I don't always do this rather, in the sense that, I've had enough practice to kind of have visualization in my head. But what I was going to say is that I do recommend having a. I don't have my pen, actual real pencil. But what I was going to say is that I do recommend having a notepad and just draw things out, and that would help. Let me get a pencil real quick. Nope, that's not a pencil. I kind of just draw it out. I kind of see, explore the properties of these things, right? And I think one thing that I would also add, and I kind of mentioned this a couple of days ago during one of those other problems, is that, in some problems you see me do this where I'm very slow. I mean, so if you're here to kind of just get an answer, explain that, well, this is probably not that, but I would also say that this is how you get better, right? When you see me, like in the future problem, hopefully anyway. And you see me doing it, the first time I do it, maybe it'll take 10 minutes. And I see a similar problem that's different, but I could use the idea and then do it in 5 minutes instead, right? That's what practice is, right? It's about, well, one thing at the very least is that it means that you don't have to reprove things that you proved in the past, and you see like properties that are, either true or false, and like, oh no, I know this to be true because I proved it last time, right? So stuff like that is how you kind of get better as well. Especially on the really harder problems, it's about like combining like 3 or 4 of these observations together, or maybe 5 or whatever, and if you spend your time proving each individual thing, then it's gonna just eat up your time, right? So yeah. Anyway, all right. Let's see. I'm drawing the first example right now, and then kind of just playing around with yeah. And I know that maybe I could draw on screen instead, but I think the way I'm still like old school. I'm old. I started old, so well, I didn't start it old, but I started a long time ago. Is what I mean. So I'm trying to think about what's the proper way to do this, right? I think intuitively the way that I would consider doing it initially is going to be with a stack, right? What would the stack? Or like a recursive stack, right? What would that look like? If we want to do it in order, then we probably do want it to. What is this head? Oh, do we just return head? Okay, and that's just the first element. So we could. That part is probably easy, but because you just take the leftmost element, right? But basically, we want to do like in order traversal is what I was going to say, to do the recursion. And then, okay. So then now, just looking at this particular example, it's going to... so now we're at 1. We want to pass in the parent, so then now 1 will point at 2 with the right, because that's the next. And then left, we leave it whatever for now. And then we go back to 2. 2 is pointing to 1 to the left, which is actually good. But what we want is return the node that is the smallest on the left when we return. Because right now 1 is a leaf. That's why I'm able to kind of just be a little bit sloppy, a little bit lazy about it. But let's say we have a 1.5. What would that look like? Well, then the next node is going to work, and then we pass. So we pass the parent. So the tricky part about this is that when we do it in place, no, okay, no, okay. I think I'm making it a little bit more complicated than it needs to be, because I'm trying to be a little bit careful, to be honest. I think one thing that I was very, I think that one thing that I'm very worried about is that if I change some, like, you can only do this recursion once, because like this traversal once, because once you change the links, you may lose the original links, right? But now that I think about it, if you keep track of the first node, you can, because I think one thing that I made a little bit complicated is that I was trying to do both at the same time, in that like both the forward links and the back links, right? But if we are able to just kind of do a sorting, if you will, then you can just traverse it the second time and then just like put everything backwards, right? So I think this is actually pretty straightforward. I think I definitely am trying to be careful, but well, I wouldn't say it's straightforward, but I think I have the algorithm in my head. So it's like a classic mathematician joke, right? Like everything you don't know is impossibly hard, and everything you do know is trivial. No matter, there's no nothing in between, right? So before I proved to myself it's right. I'm like, oh, this is ridiculous. And now I'm like, oh yeah, it's straightforward, of course, you know. Okay, so yeah, 10 minutes in though, so definitely taking my time on here, but yeah, let's do it. So the let's say head is equal to node of -1 or whatever, and then now the smallest element on the tree is going to be leftmost node, right? So current is equal to root, while current dot left is not none. Current is equal to current dot left, and then yeah, and then head dot next. It's very awkward that there's no dot next, but okay, fine. Dot left is equal to current, right? Okay, so then now this is the smallest node, right? Okay, and then now we just do a in order traversal, right, of a node. And this is, I'm going to do it like almost like a crappy Morris traversal thing, but not really. I'm just going to take care of the extra space. So then we just do yeah. So left is equal to node dot left, right is equal to node dot right. I'm having these references now. I mean, I don't know that this is necessary, but the reason why I have it as these references is because if I make changes, this will still be kept on the core stack, which will make this a very linear time thing. Or sorry, linear space thing. Obviously, it's gonna be linear time at least, but we'll see how this goes. Yeah, and then you basically process left in order node that left, in order node that right, and then do something with the current node, right? What we want is that, you know, let's say we have a previous node dot right is equal to the current node, right? And that's pretty much the idea. So previous is equal to none. Yeah, non-local prev. If prev is not none, then we do this. And then after that, prev is equal to node. So then, yeah, this is kind of a very cheesy way of doing it, to be frank. But, oh, I did lie though, because this should use left and this should use right. I think we don't manipulate the left, so we're actually probably okay here, but for code symmetry reasons, you know, it's a little bit easier to kind of figure out where you went wrong in case when things go wrong. And this is not sufficient, but we'll return head dot left and then see what complaints it gives us. Okay, yeah, no attribute is equal to right. But yeah, but now head dot left will have the node, so current is going to head dot left, and then you basically do something like while current dot left or current dot right is not none, then current is equal to current dot right. Basically now you have a linked list, and then you just have to kind of go back, right? So current dot right dot left is equal to current, and that's pretty much it, probably. And I'm probably wrong. Oh, something is none. Where is it erroring? 80, no, 86 is, that's awkward. I mean, that's an awkward error as well. Okay. I mean, we still want to debug it, obviously, because we want to submit the problem. I don't know why I say it like this. But yeah, we can just add some print statement, and maybe that'll be okay for now. Doesn't even want to print. I don't, none type is not actually right, but do I return none? It's very awkward. I don't know what the issue, I mean, this is just a very crappy error message, really. Or like, it gives me no way to kind of do anything about it, right? So I guess we can just return root, maybe. Does that give me anything? No, okay, it gives me some stuff. Yeah, okay, I mean, that's fine. But why is head dot left not right? Is this going to, Yeah, so current.left should not be, let's see, now we can at least print stuff. Okay, that's not very useful, but still nice. Okay. So what is wrong here? Is that still true here? I'm very confused. But also it means that Dong dong dong. I'm very confused why this never executes. This should at least be okay. Let's play around then. I mean, I don't know. Am I doing record? Oh, I am dumb. I get it. It turns out in code, a very fundamental thing you want to do is that's not true. A very fundamental thing you want to do is call the functions that you write so that you can kind of see stuff. I mean, now there are other issues, but that's fine, right? I forgot. I'm usually pretty good about this, but I forgot to write the base case for this one. Okay. All right. There's still an issue. Oh, I didn't make it circular. That's why. Okay. So then now we have basically a doubly linked list, but I didn't make it circular. Oh, and also I didn't return the correct one anyway. So does this give me the same error? Probably, because we still didn't make it circular, Larry. So okay. So head.left. So this dot left is equal to the last one, which is maybe current. Current is yeah, that should be the last one. And then current dot right is equal to head dot left, maybe something like that. Yeah, okay. Can't believe just a lot of silliness. Happy April Fools. I mean, it looks okay, right? So let's give it some. Before I do that, I want to test the zero case real quick. Actually, they don't always have problems with zero case, but you know, okay, good, Gucci. It's very awkward though. Whatever. Fine. If root is none, return none. Whatever. Save me a wrong answer. Hopefully, it saved me another one. Okay, good. Yeah, pretty straightforward, really. But yeah, I don't know. I just kind of got confused, I think. I'm not gonna lie. I mean, this type of problem is something that, like I said in the beginning, I just don't have that much practice on. So I'm trying to give it a healthy amount of respect and not, I don't know, not make silly mistakes, right? So yeah, I think that's all I have for this one. So let me know what you think. Hope y'all have a great weekend. I'll see y'all soon. Stay good, stay healthy, to good mental health. Goodbye and take care. Bye bye.